Today we will start our math sessions for the second term. We will start by algebra. The first unit in algebra talks about matrices, the organization of data by matrices. But first, what's meant by matrices? Matrices is the plural of the word matrix and is one of mathematical concepts which is used in modern times. It includes many branches of knowledge, science, statistics, and economics, because it displays the data and stores them. The definition of the matrix is an arrangement form of a data or a group of elements which are put in the form of rows and columns enclosed by two parentheses as the following. An example shows the application or the life application of the matrix, the use of the matrices in our life. A 3-session factory for producing some components of TV screens produces 4 principal parts of a screen A, B, C, and D as follows. The first section produces 75 pieces from A, 135 pieces from B, 150 pieces from C, and 215 pieces from D. In the second section produces 100 pieces from A, 168 from B, 210 from C, and 282 pieces from D. And the third section produces 80 pieces from A, 100 from B, 144 from C, and 64 from D. By this form, it's difficult to remember or compare these data. So, how can these data be arranged in order to analyze and benefit from them? We use the concept of matrix to organize these data by the following form. We have 3 sessions. The first, the second, the third. We said that the matrix consists of rows and columns. For example, we start from rows. Each row represents a section. For example, this is the first row, represent the first section. And the second row represents the second section. And also the third. Each section produces 4 types of the parts of the screen. So, we have here the type A, B, C, and D. Inside the parentness, which represents the matrix, we start to put the data. The first section produces 75 pieces from A. We write here 75. 135 from B. 150 from C, and 215 from D. By the same way, the second section produces 100 pieces from A, 168 from B, 210 from C, and 282 from D. The third section, 80 from A, 100 from B, 144 from C, and 64 from D. This form is called matrix. By using the matrix, we can organize this data. For example, if we want to find the production of the second section from the type B, we're going to the second section, it means the second row, and the type B, it means the second column. Here is the second row and the second column, which is what? Yes, which is 168. By the same way, if we want to find the production of the second section from the force type D, we're going to the second section, which represents the second row, and the type D represented by the fourth column, so we have to find the production, which is 282. So this form is called matrix. In which these numbers is called the elements of the matrix. The order of the matrix. What's meant by the order of the matrix? It's determined by the number of rows and the number of columns. For example, in this matrix, we have how many rows? We have here the first row, the second row, the third row. So we have 3 rows. And how many columns? Column A, B, C, and D. So we have 3 rows and 4 columns. The order of the matrix, we start from the number of rows. Here we have 3 rows, so it's 3. And then we write times the number of columns, which is 4. So the order of the matrix is 3 times 4. It means we have 3 rows and 4 columns. We're going to an important remark. The remark said that the capital letters are used to name the matrix as A, capital, B, and so on. And the small letters are used to symbolize or to name the elements of the matrix. For example, in this example, we want to list the following matrices and determine its order. We have the matrix A capital, it means the name of the matrix, and A small, the elements of the matrix, A, I, J, where I equals 1 and 2, J equals 1, 2, 3. The solution. We start here with the name of the matrix. The name of the matrix, capital letter, which is A. And then we write the parentness like this. And we have how many rows? I represent the number of rows. We have here 1, 2. We have 2 rows. And how many columns? We have 1, 2, 3. We have 3 columns. The number of rows, we start from rows. We have 2 rows. So we write here the first element in the first row and the first column. It's called A, small letter, and then the first element in the first row and the first column, here 1 represents the first row and also 1 represents the first column. We're going to the second element in the first row. In the first row it will be A, here 1 represents the number of row and 2 represent the number of column. By the same way, A, the third element in the first row. Here we have the first row, then 1, and the third column, 3. By the same way, we're going to the second row. Here, the first element in the second row. In the second row, so start with the number of row 2, and first column, we write 1. By the same way, A, 2, 2, and here A, what? Yes, 2, 3. We're going to the second example. We want to list the matrix B where I equal 1, 2, and 3, J equals 1. The solution. We write first the name of the matrix, a capital letter B, equals the parentness, the brackets, and then how many rows? 1, 2, 3. We start with the first. We write here small letter b, and then the first row, we write here 1. The first column, we write here also 1. We have how many columns? Only 1 column. So we're going to the second row. The second row, so we write a small letter b, and then the second row, then 2. And the first column is 1. We're going to the third row, small letter b, and then 3 refers to the number of the column, and 1 refers to the number of, refers to the number of the rows, and here the number of the column. Some special matrices. We have many types of matrices. We start by the row matrix. The row matrix containing one row and any number of columns. So, the row matrix containing one row and any number of columns. I need an example. We write here a matrix which contains one row here. And how many columns? For example, 4. So we write here 2, 4, 3, and negative 1. This matrix contains one row and 4 columns. So I need the order of this matrix. We have one row. So this matrix is a matrix of 1, which represent the number of rows, times 1, 2, 3, 4. 4 represent the number of columns. And this is called row matrix. We're going to the column matrix. What? Yes, containing one column and any number of rows. I need an example. We have here a matrix contains what? Yes, one column. We have here, for example, 2, negative 5, and here 3. This matrix contains one column and any number of rows. We want to write the order of this matrix. Don't forget, we start first by the number of rows. So we have here how many rows? 1, 2, 3. So we write here 3, and then the number of columns, which is 1. We're going to the third type, square matrix. In the square matrix, the number of rows equal the number of columns. I need an example. We have here the matrix which contains 2, 3, negative 1, and 7. This matrix is called the square matrix. Why? We have here how many rows? We have 1, 2. How many columns? Also 1, 2. The number of rows equal the number of columns. So this is called a square matrix, and its order is 2 times 2. We're going to another example. We have a matrix which contains 2, -1, 9, 3, 4, 8, 5, 6, and here also 5. We have here how many rows? 1, 2, 3. And how many columns? 1, 2, 3. We have 3 rows and also 3 columns. So it's a square matrix of order 3 times 3. We're going to the fourth type, 0 or null matrix. In this matrix, all elements are zeros. For example, we have here 0 matrix. We have, in this matrix, we have 2 rows and 2 columns. All the elements are 0, so it's called 0 or null matrix and denoted by this symbol. This symbol refers to 0 matrix. What is the order of this matrix? Yes, we said 2 times 2. We're going to the fifth type, diagonal matrix. In the diagonal matrix, we must know that any diagonal matrix is a square matrix. But we have an additional condition in which all elements are zeros except the main diagonal elements. Again, the diagonal matrix is a square matrix in which all elements are 0 except the main diagonal elements. I need an example. For example, we start to make, for example, a 3 times 3 matrix. Because we have here a square matrix. A square matrix. So the number of rows must be equal the number of columns. And all the elements are 0 except the main diagonal elements. What's meant by the main diagonal elements? The first element here in the first row, and then 0, and here 0. The second element in the second row, so we put, for example, 2, and here 0, and here 0. And the third element in the third row, we have here 0 in the first, in the second, in the third, for example, we write 5. This matrix is called the diagonal matrix. We're going to the last type, which is called the unit matrix. The unit matrix is a diagonal matrix. Is a diagonal matrix. But we have an additional condition in which the elements of the diagonal are all equals 1. Example. We have here a matrix. We called it the unit matrix. Unit refers to 1. So the first element here is 1. The second element in the second row is 1. And the third element in the third row is 1. And all the rest elements are zeros. Like this. Now we're going to an example. Write the type and the order of the following. Write the type and the order of the following. We start by the order. Here we have, in this matrix, we have how many row? How many? 1, 2. How many column? 1, 2. So this matrix is 2 times 2. And its type, we're going to the elements. We have here, the first element is 1 in the first row. In the first row, the second element is -1. In the second row, 0, and here 2. So it's called square matrix. We're going to the second example. In this matrix, we have 3, then 4, then 5. How many rows? We have here the first row, we have only one element, which is 3. In the second, we have only one element also, which is 4. And here in the third, we have 5. So the number of rows is 1, 2, 3. The number of columns, only 1. So the order of this matrix is 3 times 1. And its type, we said that when we have only one column, it's called a column matrix. So we have here one column, so it's called a column matrix. We're going to the last example. We have here a matrix which consists of 2 rows and 2 columns. But here we have 1 in the first row, then 0. And in the second row, we have 0 and here 3. So the order of this matrix will be first 2 times 2. But the type is what? Square, yes. But we have another additional condition. Square matrix, because the number of rows equal the number of columns. But here the diagonal or the main diagonal elements is 1 and 3, and the rest are zeros. So it's called a diagonal, yes, matrix. Then we're going to equality of 2 matrices. Equality of 2 matrices, or the equivalent matrix, are 2 matrices which are equal. Yeah, the 2 matrices are equal if and only if. The 2 matrices are equal or equivalent if and only if they have the same order and the corresponding elements are equal. Again, we have 2 conditions for the matrices to be equal or equivalent. The first condition, they must have the same order. This is the first condition. And the second condition, the corresponding elements are equal. Example. We want to find the value of x and y if these 2 matrices are equal. We said that these 2 matrices are equal, so they must have the same order. Here, the order of the first matrix is, yes, 2 times 2, because we have 2 rows and 2 columns. And also the second, we have 2 rows and 2 columns. The second condition, the corresponding elements must be equal. Here, the first element in the first row and the first column is what? X plus 5. X plus 5 here, the first element, first row and first column. We have here the element in the first row and in the first column is what? 2. So these 2 elements must be equal. These 2 elements must be equal. We write here x plus 5 must be equal to. By inversing the sign, here x will be equal to, by the opposite sign here plus, we change by negative, it will be equal -3. By the same way, we're going to here the second element in the second column, which equal -14, and the second element in the second column in the second matrix, which is 2y plus 2. 2y plus 2 must be equal -14. We have to inverse the sign. First, 2 here is positive, we change the sign to be negative. So 2y will be equal -14 minus 2, which equal -16. And we want to get rid of 2. Here times we change it to be divided. Then y will be equal -16 divided by 2, which equal -8. We get first the value of x, which equal -3, and the value of y, which equal -8. We're going to multiplying a real number by a matrix. Consider K is a real number, and we have a matrix from the order 2 times 2, which contains x, y, z, and l. We want to multiply the matrix by this real number. Here, we start to multiply this real number by every element in the matrix. So, the answer will be k times x, which equal kx. K times y, which equal ky. By the same way, in the second row, k times z equal kz, and kl is the last element. For example, we have here -2. We want to multiply this real number by the matrix, which contains 4 elements, by this way. -2 times 4. -2 times 1. And we're going to the second row. -2 times 5. The last element, -2 times -1. We get the answer. -2 times 4 equal -8. -2 times 1 equal -2. And then -2 times 5 equal -10. And the last element, -2 times -1 equal 2. We're going to transpose of the matrix. Transpose of the matrix. What's meaning by transpose of the matrix? If the rows are replaced by columns and the columns are replaced by rows in the same order. For example, A is a matrix. A is a matrix. I need the order of this matrix. Here the number of rows 1, 2. Yes, the number of columns is 1, 2, 3. So the order, we start with the number of rows 2, and then the number of columns, which is, yes, 3. We need to get the transpose of the matrix A. First, we can symbolize the transpose of the matrix A by A and here T. Small letter T. And then we have to what? To replace the rows and the columns. To replace the rows and the columns. Start first with the rows. The first row is what? Contains 1, 2, and -1. We change this row to be a column. So we write here 1, then 2, then -1. And the second row is what? Contains 3 elements, which are 3, -1, and here we have 5. It changes this row to be a column. Then we start with 3, -1, and here 5. I need the order of this matrix. Yes, we start with, the number of rows. 1, 2, 3. Here we have 3. The number of columns. 1, 2. So we write 2. So the transpose of the matrix A is A. We have here T and here. If the matrix in the order 2 times 3, its transpose will be 3 times 2. Excellent. Remark, we must know that A transpose equals A. A transpose equals what? A. We're going to the symmetric and skew symmetric matrix. What's meant by symmetric and skew symmetric? First, symmetric and skew symmetric matrices are square matrices. So the first condition, the two matrices must be square. So if A is a square matrix, then A is asymmetric if A equal A transpose. And A is a skew symmetric if A equal -A transpose. Again, symmetric and skew symmetric matrix. If A is a square matrix, then we have two conditions. A is asymmetric if A equal A transpose, and A is a skew symmetric if A equal -A transpose. We're going to the last example. Is the matrix B symmetric or a skew symmetric? We have here the matrix B. To get the matrix B symmetric or a skew symmetric, we must first get B transpose. Excellent. B transpose. How we can get B transpose? Yes, we change. Yes, here each row to be a column. Here we have the first row is what? Contains 0, 1, and -1. We change this row to be a column. So we write here 0, 1, and -1. The second row, it will be the second column. -1, 0, 3. By the same way, the third row, it will be the third column. And we look to B and B transpose. Here, we can deduce that B transpose equals -1 times the matrix B. It will be equal -B. So, B equal -B transpose. So from the rule here, B is a skew symmetric Thanks.